Okay, so how many liters of a 0.500 molar solution of sulfuric acid are needed to completely react with 12.0 grams of sodium hydroxide? So first thing you gotta do is know what you're starting off with, your known, and what you're trying to find, your unknown. So you're starting off with grams of sodium hydroxide, and you're trying to get eventually to liters of something. So this is a grams to liters conversion, so that means we need molar mass eventually, and also you got to use that molarity up there. So first thing we got to do is balance the equation. You guys know how to do that. I think y'all kind of love doing it too, because it's easy stuff, right? Alrighty, so let's do this. So 2 NAs, I'm sorry, up there. Let's see. So I have, see how many H's I got. 4 on the left, so I'm going to put a 2 up here. And I have 6 O's on the right, and I have 6 O's on the left, so I'm balanced. Alrighty. So let's start off. So 12 grams of NaOH. So this is molar mass on my second fraction, my conversion factor. So it'll be 39.998 grams NaOH. And on the top, it's going to be the 1 mole of NaOH. So I need to switch out of this. So I got to do my mole to mole ratio. So I'm going to use, let's see, this right here. So this is 2, if you can see that, moles NaOH. And I'm going to use this one for trying to get to H2SO4. 1 mole H2SO4. So if you look, you have something up here on top, and this is your key. So the way to rewrite this for a conversion factor is 0.500 moles H2SO4 over 1 liter. So that means that I got to put 0.500 moles H2SO4 on the bottom, and on the top it's going to be 1 liter H2SO4. So do my math. So it's 12 divided by 39.998 times 2 times 0.5. Actually, it's the same number. And divide the 2. So I end up with 0.300015 dot dot dot. I have 3 sig figs, so my answer is 0.300, and then I'm liters, so liters of 0.500 molar solution of H2SO4. Okay. Okay, so let's move on. What volume of 0.250 molar solution of NaCl is necessary to just consume the solute in 0.50 liters of a 0.100 molar solution of lead 2 nitrate? So this is my known. It's a volume. My unknown is another volume attached to a molarity. So that means I'm going from liters to liters. So we got to use both of those capital M's in our stoichiometry. So balance first. Let's see, I have 2 NO3s on the left, so I'll put 2 up here. I have 2 Cl's on the right, so I'll put 2 up here. I have 2 H's on both sides, and I'm good. Alrighty, so 0.150 liters. PbNO3. 2. Okay, so make this longer. Alrighty, so I gotta use my number, my molarity, right next to those liters. When it says of something, that means they're grouped together. So it will be 0.100 moles lead 2 nitrate on the top, 1 liter on the bottom. So right now I am going to get out of moles of lead 2 nitrate by doing my mole to mole ratio. So I have 1 mole PbNO32 on the bottom, And on the top I got 2 because I'm trying to get to HCl. Alright, so now I look what volume of this. So I use these moles and this molarity up here to switch out to liters. So I got to put 0.250 moles HCl on the bottom, and on the top it's going to be 1 liter HCl. Do my math. 0.15 times 0.1 times 2 times 1, that's 0.03 on top, and on the bottom it's going to be 0.250. Divide the 2, I end up with 0.12. I have 3 sig figs in my problem, so I've got to add a 0, and I'm going to put liters of 0.250 molar solution of HCl. Okay. How many liters of a 1.2 molar solution of HCl is needed to dissolve 5.8 grams of aluminum hydroxide? So this is grams to liters. Still 4 steps. I got to use molar mass and then molarity eventually. So I'm starting off with this. This here is my unknown. I'll group that together. So now first I got to balance. So I have 3 CLs, I'll put 3 here. Let's see. I have 3 O's on the left. I'll put 3 over here on the right for now. I have 6 H's, and I'm balanced. So I start off with 5.8 grams of aluminum hydroxide. So then now molar mass, 1 mole ALOH3. The grams is going to be the following: 26.98 plus 3 times 16 plus 3 times 1.008 is about 78.004. So I'm going to use my mole to mole ratio. So 1 mole ALOH3. And on top it's going to be, let's do a different color for that, 3 moles HCl. Okay, so now I want to get to liters. So if you notice, I have that grouped together. I circled this in green right here, so those are stuck together. So I have 3 moles of HCl, so that means I got to put moles of HCl on the bottom. The only thing left is going to be liters because of molarity. So I have 1.2 capital M, so I'll put 1.2 next to the moles here on the bottom, and now I can do my math. 5.8 times 3, 17.4, then 78.004 times 1.2, so that's 93.6048. Divide the 2 numbers, I end up with 0.185887 blah 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 blah. So I have 2 sig figs, so my answer is going to be 0.19 liters of 1.2 molar solution HCl.